everyone. So this is just like some very basic stuff, just like projectile motion, multiple calculus, stuff like that. Just curvature, torsion, very very basic stuff. But I'm just going to like solve some exercises just to like get back in shape essentially. But yeah, let's just get started. So there's some limit continuity thing like the epsilon delta definition and all that, and I'm just gonna skip all of these examples because I don't care about all of this. But once again, the definition basically they're saying is like, let's say you have a vector valued function like f of x vector, right? So then as x approaches x naught, right? So the limit as x vector tends to x naught vector, your f of x, let's say this tends to L, right? So what that means is basically like for all epsilon greater than 0, there exists some delta such that for a sphere around a solid sphere around your x naught point, so basically for all like or you know what, just write it as an application. So basically for this sphere, the norm of x minus x naught, this thing is less than delta, right? Whenever this happens, this automatically implies that the function value, so f of x vector minus, so f of x naught, which I should say just L, so minus L, this thing, the absolute value, this thing will be like less than epsilon. So that's just our usual epsilon delta definition. But yeah, let's just get started. So skip all these examples, just I don't really need all of this. So there's all of this other stuff, the product rule, quotient rule, all that, which is basically saying like you can break your limits, right, into a bunch of limits and some simple arithmetic operations between them. So okay, this is for differentiation, by the way, but there is also stuff for the limits thing, but we won't really care about anything. We just want to solve some problems. Right, so I think this is the exercise. Sure. Okay, let's just get started. Question 1 is in exercise 1 to 4, r of t is the position of particle, whatever. Find an equation in xy whose graph is the path of the particle, right? Basically a relation in xy. So this is in the xy plane. Okay, find the particle's velocity. So you're given some sort of parameterization, you just want to find the, sure, find the particle's velocity, acceleration, vector, whatever. So this let's just get started. Fearing this stuff, it's getting in the way. Okay, so the screen guard is really messed up. So the first question is just like r of t equal to t plus 1, all that stuff. So the t plus 1 equal to x, or just t equal to x minus 1. So what do you just have like y equal to x minus 1 squared, which is like x squared minus 2x plus 1. That minus 1, so that's just like x squared minus 2x. So there you go, x squared minus 2x equal to y, or I could just say x squared minus 2x minus y equal to 0. So that's or okay, whatever, we don't care. Second is r of t equal to this stuff, so 1 by t is equal to y, so it's basically like t is equal to, or yeah, okay, whatever. So our t is just like 1 by y, so basically just have like x equal to 1 by y upon 1 by y plus 1, or you can just divide the whole thing by 1 by t, so it just basically becomes like 1 upon 1 plus y, right? So all you have is like x plus xy equal to 1. That's your equation. So that's both of these were like conic sections. Once again, we don't really care, we won't graph any of this, we just want to find relations, right? Okay, cool. Oh, so you want to find the particles, find an equation whose graph is the path of the particle. Okay, then also find the particle's velocity and acceleration vectors. So you already have the relation in terms of like t. So okay, I'll just make a chart sort of a thing. So this is our relation. You'll have the velocity and the acceleration. Sure. So for the first question, it was just like the velocity would just be like 1 comma 2t at t equal to 1, so that's just 1 comma 2, and you want to find the vectors, right? Not anything else. So just 1 2. The acceleration would just be like, take a derivative of that, so it's like 0 comma 2, so it's constant. Sure. So just 0 2. Just fast. Okay, the next one, so the second one was just like take a derivative of that stuff, so it's just t upon t, so it's like t plus 1 minus 1, so it's like 1 minus of 1 upon t plus 1. So take a derivative of that, it just turns out to be 1 upon t plus 1 squared, and this is just negative 1 upon t squared. Sure. So just put t equal to negative 1 by 2, so that's like t plus 1 by 2 is just 1 by 2 squared. So in any case, it doesn't really matter, it's just 1 by 4. So what you essentially get is just minus of 4, so it's 4, so it's minus 4 comma 4. That's your velocity, right? So it's minus 4 comma 4. Your velocity was essentially what? It's just minus 1 upon t plus 1 squared, comma what? Negative 1 upon t squared. Take a derivative of that. It's just minus, so it's 2 upon t plus 1 cubed and 2 upon t cubed. Put at t equal to, once again, that. So it's just like 8 negative, obviously. So just negative 8, and this thing is, oh, so that is negative 8, and this thing is positive 8. So just 8 comma negative 8. Yes, that hopefully is correct. Yeah, I think this is correct. Okay, next, the third one is, so it's just e power t, all that stuff, t equal to natural log of 3. So once again, find a relation first. So that's like, once is really just 2 by 9 x squared. Come on, why am I even doing this thing? So it's just like 9y equal to 2x squared, some sort of a y squared equal to 4x sort of thing. Parabola, but like, never mind, forget the shape. Okay, so we wanted the velocity and all that, so it's just gonna take that e power t common, because yeah, and this is like 1 comma, so 2 by 9, but then the 2 comes out, and then there's the e power t, right? Yeah, you know what, scrap that. Why take it outside, right? So just e power t comma 2 by 9 is 4 by 9, 4 by 9 e power 2t. That's a velocity vector, and then acceleration is just like e power t, and then you got 8 by 9 e power 2t. I mean, this is just really just gonna stack up a bunch of times. So at t equal to natural log of 3, basically like e power t equal to 3, what happens is this is just 3 comma, that's 3 squared 9, so just 4, and this thing is once again just 3 comma same stuff, so just this. Yeah, so it's 3 by 4 comma 3 by 8, 3 by 4, 3 by 8, I mean 3 comma 8, whatever. Fourth is r of t equal to cosine 2t, all that. So sure, you can find a relation, just square that, add that, all that. So just like x squared plus y squared upon 9, that's equal to 1. That's an ellipse. We've seen this a lot, 1,000 times. Okay, also just take a derivative of this stuff. So just like negative 2 sine of 2t comma what, it's negative 6, not negative, it's 6 cosine of 2t. Cool, that's a velocity, and the wait, that was a t. So whatever, take a acceleration, so just like minus 4 cosine of 2t comma negative, now it's like proper negative 12 sine of 2t, and at t equal to 0 essentially. So this is gone, and that's 1, right? And over here this is gone, and this thing is 1, so it's 0 comma 6 and minus 4 comma 0. I really hope this is going correct. If it's not, I don't care. I mean, it's not like I actually have things to tally it with, like, but anyway, fifth question. We don't need this table anymore. Sure. The fifth is, so 5 to 8 give the position vectors of the particle along the various curves in the xy. Okay, so given that, find the particle's velocity acceleration vectors as the stated times. Okay, once again the same stuff. Sketch them as vectors on the curve. Oh, okay, you want me to sketch all of that? I'm not going to do this. I'm just going to continue what I was doing beforehand, like, yeah, because a computer can graph it for me. I won't, like, I'm lazy. Okay, fifth is r equal to sine t, or just like e power, not exactly, okay, it's switched, but whatever. So it's sine t cosine t, and equal to pi by 4. You know, never mind, just do it organically. So the same stuff, x squared plus y squared equal to 1. It's just a circle, obviously. Okay, I can kind of graph this already, but okay, this is also a circle. What is this? This is a cycloid. What is this stuff? This is a parabola. Hey, you don't even have to, oh, okay, this is already like y equal to x. That's interesting. So it is a cycloid. Okay, it's given to us. Never mind. So yeah, okay, the equation was given, so why am I writing? Never mind. What we want is the velocity and the acceleration. So the velocity is just cosine t comma negative sine t at equal to pi by 4, just 1 by square root 2 negative 1 by square root 2. And the acceleration is, so just what, negative sine t comma negative cosine t at pi by 2, and just negative 1 comma 0. Hey, something is messed. Oh, okay, right, it equal to, right. So this is supposed to be a t equal to what? T equal to pi by 4, and then at pi by 2. So fifth is just t equal to pi by 4. So at that point, negative cosine t negative sine t is just, okay, sure, 1 by square root of 2 negative 1 by square root of 2. whatever. Sixth, not sixth, t equal to pi by 2, that would be, so this would just be like cosine t comma negative sine t, but then cosine of pi by 2 is 0, so just negative 1, 0 comma negative 1, and this stuff is just negative 1 comma 0. Sure. Next, sixth is r is whatever. We just want to, so it's half of, like, it's just gonna be like 2, so negative 2 sine of, okay, cool, at t equal to pi, so this is pi by 2, so that's 1, this is 0 in any case, so just negative 2. Okay, so first we're doing a t equal to what? T equal to pi, and then t equal to 3 pi by 2. Sure. So at pi, this is just this pi by 2, and then we got negative what negative 2 sine of yes, so that's just 1, so it's negative 2 comma 0. What about the acceleration? So just have, so both will be negative, and the 4's cancel out, so it's just like cosine of t by 2 sine of t by 2 at pi. So this is 0 and this is 1, so just negative 1. Cool. And at 3 pi by 2, so 3 pi by 2, once again this seems to be minus of sign over there, so 3 pi by 2 by 2 is 3 pi by 4, so it's like, it's this stuff, negative 2 sine of 3 pi by 4 comma 2 cosine of 3 pi by 4. Now 3 pi by 4, the sine of that, hey, I'm forgetting, sine of pi by 4 is just this stuff, so it's like, this is cosine, I mean, it doesn't really matter because it's the same thing. Hey, so it's pi minus, right, it's the same, but cosine, it's negative. Sure. So this thing is negative 2 by square root of 2, just negative square root of 2. This thing is also the same thing, so it's just negative square root of 2. That's a velocity. What about your acceleration? It's just, well, that's going to cancel off, so just negative of cosine pi by cosine 3 pi by 4 sine 3 pi by 4, which is what? First is the cosine, which is positive. Sure. So it's just, yeah, I'm doing it correctly. So just the 2 cancels out, right? It's just 1 by square root of 2. 1 by square root of 2 comma negative 1 upon square root of 2. Okay, yes, this is it. Yeah, okay, seventh is motion of the cycloid, but we don't care what it looks like. I mean, I could technically graph that, it's not so hard. I've even done this in my engineering graphic course, but who cares? Why graph this? We probably should graph this. So its y coordinate is 1 minus cosine of, so what's the mean value of this, first of all, right? So the x coordinate is like moving forever. Hey, why is this minus sine of t? Oh, because the center is moving at a constant velocity, and then that thing is rotating. So yeah, sure, that actually makes sense. The amount that you have, so yeah, exactly, t arc length has been moved, so that's your angle that you're making, and that turns out to be this. Yes, it does turn out to be this, because you're doing a minus pi by 2 extra, and that's why it's this stuff. Okay, so okay, the derivation is cool, and okay, so it's going to be something like this. So at t equal to 0, it's here, and then it's going like that. So this happens when your y coordinate is 0, so that happens at t equal to 2 pi, t equal to 2 pi, at which point your x coordinate just is 2 pi, so t equal to x equal to 2 pi, and then so on. That's your cycloid. Anyway, so what we want is at t equal to pi and 3 pi by 2, so pi would be somewhere over here, velocity is going like that, and at 3 pi by 2 it's here, so velocity is going like that. So it should just have an x coordinate, no y coordinate, which makes sense because that thing is like a positive sine t. So at, hey, 3 pi by 2, that, this is pi, not, oh, okay, this is pi, this is 2 pi, right? And this is 3 pi by 2. So here it's like, it's this, so it's gonna be at 45 degrees. Sure. Okay, so over here you shouldn't have an x coordinate, which is cool. I mean, take a derivative, just like sine, so it cancels. You also want the acceleration, don't you? I'm just gonna take the whole thing directly. So this is just 1 minus cosine comma positive sine, and this thing is sine comma cosine, right? So at t equal to pi, this is just 2 comma 0, and at, and this stuff, t equal to pi, it's 0 comma minus 1. Hey, what? Oh, okay, yeah, I mean, it is 0 comma minus 1, come on, that's correct, the acceleration is going downwards. over here the acceleration will be moving something like this, because the center does not really change. So according in that frame of reference, acceleration is just like as if it was moving around the circle, right? So even in this frame it's the same, because your velocity just adds. Never mind, why am I asking the physics? Like, okay, so this is at t equal to what? T equal to pi. We want a t equal to 3 pi by 2. That's gonna be easy. So just 1 minus cosine of 3 pi by 2, which is like pi plus pi by 2. So that's negative, and it's just 0 in fact. So it's just 1 comma, this is just x increasing is pi by 2, it's just 1, and this stuff is sine of 3 pi by 2 is, I'm missing something. No, I'm not missing something. 3 pi by 2 is a full rotation like that. Sure. Yeah, the cosine is just 0. The sine would be, hey, the sine would not be 2. Okay, it's supposed to be negative 1. Sorry for that. I don't know what's going in my brain. And 3 pi by 2, your sine is negative 1, cosine is 0. So it's just next. Yes, something was really messing with my brain. And does this make sense? I mean, yes, it does. 1 comma. Hey, what? Can't be minus 1. That doesn't even make sense. Okay, I messed up, didn't I? 1 minus cosine, and then you got sine. This shouldn't be negative. This shouldn't be negative. In the y direction, it's not negative 1. It's positive 1. So why did I not get that? What did I do exactly? Taking a derivative of that, so just minus cosine t, and you got positive sine t. Yeah, that seems okay. Sine of 3 pi by 2, that is negative 1, right? Yes. This should be pointing like this. Why is it not pointing like that? I messed up the velocity, but I do not understand how I messed it up. At 3 pi by 2. Oh, because this isn't 3 pi by 2. 3 pi by 2 is not here. This thing is 5 pi by 2. This is 3 pi by 2. And yes, here it is just like that. And the acceleration should be pointing like this, perpendicular to it. Which is, it is, I mean, it's perpendicular. Is it? No, it's not. Over here it was. Over here this should be like 1, right? Cosine of 3 pi by 2 is 0. Hey, what? Nothing is 1 over there. What? Oh no, because it's not necessarily perpendicular. It's not. The you have to remove the velocity component, which is like remove the one thing. So it's actually like this. So it should be like this. Yes, that makes sense. So it's okay. Next, physically it makes sense at least. Okay, eighth is motion on the parabola y equal to x, whatever the usual parameters. So we want to find the velocity. Sure. So the velocity is just like 1 comma 2t, and acceleration is 0 comma 2. And acceleration is 0 comma 2 at all points. And we want at t equal to minus 1, 0, and 1. So it would be like 0 comma minus 2, 0 comma 0, 0 comma 2. And I'm not gonna graph anything. So this is at t equal to minus 1, 0, 1. Okay, move on. Move on to the ninth. There is the ninth question. Right, motion in space. R of is the position of particle in space and time to find the particle's velocity and acceleration vectors when find the particle speed and direction of motion at the given value of t. Find particle's velocity. Wait, what? Speed. So the magnetic velocity and the direction of the motion. Sure. Find the particle's velocity at that time as the product of its speed and direction. Sure. I mean, kind of. Okay. Cool. So just a bunch of calculation really. So just ninth. So from this point onwards, it's all just like find the velocity vector, find the magnitude of the velocity, and find the b hat thing. It's not magnitude. Your unit vector, right? So this is a weird mental math thing because I'm doing calculus in my brain now. But yeah, so this is like 1 comma 2 t comma 2 at t equal to 1, which is 1 comma 2 comma 2. So this is 1 comma 2 comma 2. Velocity, which is like 1 upon square root of 4 plus 4 is 8 plus 1 is 9, so just 1 by 3 of this thing. So this would just be 3, and this is going to be just I mean, it's kind of obvious what this is, but like, should I be writing down this stuff? Just do it. Just write it down. This is like 1 by 3, 2 by 3, 2 by 3, whatever. Next, 10th is this stuff. Consecutive derivatives like 1, 1, 2, t, 1 comma square, t equal to what? Pi by 2. So, okay, t equal to 1, sorry. So it's just like what? 1 square root 2 and 1. Yes, 1 square root 2 and 1. 4, sure, 1 by 2. This is like 1 by 2, 1 by square root of 2, 1 by 2. Next, 11th is sec, okay, tan t equal to pi by 6. What's at pi by 6? What's cosine of pi? Oh, 30 degree. Cosine of, that's like 3 by 2. Secant square. Secant t tan t. What is that going to be? Secant t tan t. So 1 by cosine t and then sine t by, sure, so it's sine t upon cosine square t. Sine t is 1 by 2 upon 3 by 4, which happens to be 2 by 3. So this is 2 by 3 comma, yes, correct, 2 by 3 comma, this is just secant square of t, so it's just 1 upon 3 by 4 squared, so 3 by 2 squared, so it's like 3 by 4, so it's just 4 by 3, 4 by 3, and what is this? This 4 equal to 5, so it doesn't matter, 4, sure. So the magnitude of this stuff is just like, they can write it as like 2 by 3 times 1 comma 2 comma 6. So the magnitude is like 2 by 3 times of this stuff is like 1 plus 4 plus 36, which is a 41. Oh, bad number, but sure. So it's just 2 by 3 square root of 41. So divide by that. This 1 square root of 41 times this messed up stuff 126. I really hope this is the correct thing. It is, right? Yes, it certainly is. Next, I should just stop thinking sometimes. Okay, I have to trust my calculations a bit. 12th is, oh, this was 12th. Oh, okay. This was 12th. So 11th is 2 cosine of t, 3 sine of t. I haven't done this before, I don't know. At equal to pi by 2, so sine is 1, cosine is 0. So sure, so it's just minus 2 comma 3 comma 4. Right. Yeah. Oh, not 3 because it's supposed to be 0, right? So the cosine stuff is 0. Yes, minus 2 comma 0 comma 4. So you can do it like 2 times of 1 plus 4 is like 5. So it's just 2 square root of 5. Divide by that. You just got 1 by square root of 5 and then negative 1 comma 0 comma 2. This is really, it just feels like I'm back in high school. But hey, so this is 13th. No, this is 11th. 13th is what we're going to do next. 2 natural log of t plus 1 plus t square by 2 t equal to 1. Take a derivative is like 2 upon t plus 1 at t equal to 1. So let's just 1. So 1 comma 2 comma 1. Sure. It's like 4 plus 2 is 6. So just square root of 6. Okay, just divide. So 1 square root of 6, 1 comma 2 comma 1. So they told me to write it as the speed times the, v hat thing. But like, what's the point? You already have the v vector thing, right? So you're just going to do unnecessary calculations. Anyway, 14th, it's e power negative t to cosine or whatever. At equal to 0, just take a derivative like, oh, that's 1, sure. So it's just negative 1 comma negative 6 and then sine of 2. That's gonna cancel out in any case. This is cosine is 1, so negative 1 comma 0 comma 6. Yeah, sure. So this is like 1 by square root of 37. What? Negative 1 comma 0 comma 6. Okay, next thing. This is really just getting out of hand. Okay, this is 14. 15 is, okay, when will the good questions start? The sensible ones, the one where I'm not just feeling like a calculator, like where I feel like a human. Okay, so this was question 14. Question 15, let's go. Question 15 is, okay, so in these exercises, R of t is the position of particles. Find the angle between the velocity and the acceleration vectors at time. So okay, you need to find the velocity, you also need to find the acceleration, and then you need to find the angle. So your theta, or let's just say the cosine theta at least, right? Because you just have to take the cosine inverse of that. So, oh, this is going to be a long night. And then you have to have theta. Okay, let's just get started. So 15th is r of t is this stuff. So your velocity is just like what, 3 comma square root of 3 comma 2t, and we want to do it at t. Oh, so everything's at t equal to 0. Amazing. So it's just 3 comma square root of anyway, the acceleration is just 0 comma 0 comma 2. So this would be 330, and this is your acceleration. So you know, you just forget this square root 3 stuff. It just becomes like square root 3 comma 1 comma 0, and this is like this. So it's the angle between that, which is like what, take a dot product, just 0 in fact, so it's already 90 degrees. That was funny. Okay, and then your theta is like what, pi by 2. Okay, cool. So 16th is r of t is just 1 plus square root of 2. I'm just gonna, oh, t equal to 0. I mean, yeah, that's okay. This is 1 by square root of 2 comma it's gonna be 1 by square root of 2 minus, that doesn't really matter, it's just 1 by square root of 2 essentially. Okay, what about the other one? So that's 0 0, and then you got minus 32. Right. So then this wait, what? Not like this. Okay, this is the better thing, right? So minus 32 over there, angle between that, right? So it's just like what, 1 1 and then 0 minus 1. So it's just, we just have a 1. This is already unit vector, so take a dot product, minus 1. Cool. 0. No, wait, it's not 0, it's negative 1 upon square root of 2. So it's negative 1 upon square root of 2, that's your cosine theta. What does it mean? The angle is obtuse, and it's pi minus pi by 4, which is 3 pi by 4. Sure. Next, 17th is natural log of t square plus 1 tan inverse of t square root of whatever stupid stuff. 1 upon t square plus 1 at t equal to 0 is just 1. So that, there you go. 1 comma, let's not actually write this down. So 1 upon t square plus 1 comma, just that, just exactly that. Hey, that's the thing, right? Tan inverse of t. Who is messed up about this stuff? Tan inverse of t. This is the, or was it the square root over it? I am really forgetting stuff. I mean, what? How do you integrate this stuff? Hey, how do you integrate, differentiate d by dt of tan inverse of t? Let tan inverse of t be theta, just d theta by t tan theta, which is like 1 upon secant square of theta, which is like cosine square of theta, which is like, or you could just say 1 plus that stuff. So it's just like 1 upon 1 plus t square. Sure, the derivative is the same. That's crazy. Oh, okay, obviously, because this is supposed to have a 2t over there. I am stupid. Anyway, so the derivative is that, and this is, sure, so the 2 cancels out, so just t upon square root of t square plus 1. Amazing. And we wanted what, t equal to 0, so it's just going to be 2 upon, this cancels, so 0 0 comma 1 1, the acceleration, I hate this. So taking derivative of that doesn't really matter, so the only thing that will matter is like 2 upon t square plus 1. Taking derivative of this stuff won't matter because you will have a t introduced, so well, it's 0 in any case. And once again, taking derivative of this doesn't really matter. Take a derivative of that, it's 1 upon square root of t square plus 1. So it's just 2 comma 0 comma 1. Yeah, and so taking a dot product is like 1 upon square root of 2, square root of 4 plus 1 is 5, so 1 upon square root of 10. And I have no idea what's the cosine inverse of that, but hey, move on. Okay, I guess I could probably figure it out somehow, but nah, never mind that. Like cosine theta is 1 upon square root of 10, then okay, no, it's probably not a good idea. Yeah. Okay, 18th is r of t equal to 4 by 9 stuff. So you want to derive it. Sure. T power 3 by 2 So just 3 by 2 is just what? 2 by 3. 2 by 3, 1 plus t to the power of 1 by 2, comma, this 3 by 2, once again the same stuff, 2 by 3, but negative, so negative 2 by 3, 1 minus t to the power of 1 by 2, okay, and 1 by 3, it's your velocity. But acceleration is 1 by 2, 1 by 3, 1 plus t power, negative 1 by 2, take that outside, so it's negative is positive. So it's just 1 by 3, 1 minus t to the power of negative 1 by 2. None of this is going to matter, but still. So it's just 1 by 3, 1 by 3, 0. That's an acceleration. Your velocity is 2 by 3 minus 2 by 3. What is this stuff? 1 by 3. So this is like 2 minus 2, 1, and then 1, 1, 0. Take a dot product, it's just like that cancels, just get 0. So this is pi by 2. Ah, interesting. Is this like, nah, don't think too much, just move on. So that's 18th. Okay, this is that table is done. Let's go to the next section. I did not have an idea that this would be such a long and tedious exercise. Okay, tangent to the curve, as mentioned in the text, the tangent line to a smooth curve is the line that passes through the point action parallel to V. Okay, the curves, find parametric equation for the line that is tangent to the given curve at the given parameter value t equal to t1. Sure. I mean, yeah, so you're given some t values, will have some r of whatever t naught is. So all you have is like r minus r naught, that's equal to your, you know, some lambda times v vector at 0, I mean, t equal to 0 or whatever, t naught, sorry. But yeah, just tangent line, we don't even have to find a tangent unit vector or anything. Sure, so just let's get it started. So what we'll need is the velocity vector, obviously, the r0 thing, so at t equal to 0, your velocity vector at 0 in fact is what kind of we need. And what else would you need? So r is just r naught plus all that stuff. So your equation, so just like r naught plus t times of v naught vector, right? Or you could just say, I'm calling it capital T, but don't be like confused by that, because it's really just supposed to be anything collinear to v naught vector. Okay, cool. So let's get started. First, 19th. So your r at 0 is just 0 comma minus 1 comma 1. Okay, your velocity is, that's cosine of t equal to is 1 comma 2t. Okay, sign doesn't really matter, so just 2t basically at t equal to, because that cancels in any case, that's 0, this thing is 1. So what do you have? Just have just t times of that, so just like t comma minus 1, so nothing, so just minus 1, and then 1 plus t, I suppose, yes, 20 is right. So r would just be like 0 comma minus 1 comma 0. Your velocity would just be like, so t square, oh okay, at t equal to 2, you can't just do that. So at t equal to 2, it's 4 comma minus 1 is 3, 8. Okay, and this stuff is what? So it's got 2t times 2 is 4, and then you got 2, just 2, and this stuff is 3t square, so 3 times of 4, just 12. Right, so I can just reduce this to something. So this reduces to just this was 3, right? Yes, this was 3. Okay, I can't reduce this further because it's 4 here co-prime. Okay, cool. Fine, so just gotta deal with it. So it's just 4 plus 4t comma 3 plus 3t comma 8 plus 12t. And yes, I could simplify this. I could use t plus 1 as u, and but never mind all that. 21 is r is just this stuff at t equal to 1, but this is just 0. So 0 comma 0 comma t equal to 1 is 0 once again, 0 comma 0 comma once again 0. Wow, that's amazing. So this is 1 upon t, right? So this is 1 1, and this stuff I've seen, this is plus 2 minus 2 is minus 3, so minus 3 upon t plus 2, the plus, so that's 1, so this doesn't matter. So minus 3 upon this stuff is like 3 upon t plus 2 squared at t equal to 1, so 3 upon 3 squared, 1 by 3. This one is easy, natural log of t, that's 0, and then just got t upon t 1, so yeah. That seems okay. So oh yeah, r is just nothing, so I just like this stuff, so it's like I'm just gonna make it 3 comma 1 comma 3, so it's 3t comma t comma 3t. Yes, next 22. 22 is r is this stuff at t equal to pi by 2, so cosine is 1, sine is, and this sine 2t stuff is 0, so yeah, sure. And sine is 1, cosine is 0. Okay, so this was like negative, so first just find this stuff out. 0 comma 1 comma, this is also 0, and this is minus sine, so just minus 1 comma, this is cosine is 0, and then it's like 2 cosine 2 something, so 2 cosine of pi, yes, so it's just minus 2. Okay, cool. So yeah, sure, I'm just gonna be like, what, this thing is minus t comma 1 and minus 2t. Next it's 23. 23 is this is just a mundane activity. Here are examples. Motion along the circle, each of the following equations in parts A to E describe what A to E. Oh, this is A to E. Describe the motion of a particle having the same path in the unit circle, although the path of each particle in, okay. The behavior or dynamics of each particle is different. For each particle, answer the following questions. Does the particle have constant speed? If so, what is the constant speed of the particle's acceleration vector, always orthogonal to the velocity vector? Does the particle move clockwise or counterclockwise along the circle? Okay. Does the particle begin at 1, 0? So, okay, cool. Shouldn't be hard. So, the questions we want to do is, so just 23, and so you have like A, B, C, D, E, and what quantities do you want? So this particle have constant speed, so just the velocity vector firstly, and the acceleration vector, velocity, so the speed, right, orthogonal to its, so so basically just want to have, is it constant speed? So constant speed, or is it like, okay, so perpendicular, so it's like V perpendicular to A. What else? This particle move clockwise or counterclockwise? So just, is it moving counterclockwise? Sure, that makes sense. Just start. A is, so RT equal to cosine theta, it's just e power t basically. So does this have, yes, so these are in fact perpendicular, so that's true. The constant velocity, yes, that's also true, it's just 1 all the time, so velocity vector is just that, just negative sine t cosine t, and your acceleration is just invert that, is just minus cosine minus sine. Okay, and is it going on anti-clockwise? Yes, it is going anti-clockwise. B is, okay, it's the same old, so it's just minus 2 sine minus 2, not, okay, just 2 cosine. The acceleration is just that, it's minus 2 cosine minus 2 sine. This is a constant speed, yes. Is this perpendicular? Yes. Is this, yes. C is cosine of, okay, just adding a phase. How is this any different? Oh, also the fourth is, does the particle begin at 1, 0? Yes, in these two cases it does begin at 1, 0, but here it does not. Begins at minus pi by 2, so that's certainly not 1, 0. This is also 1, 0, but now it's rotating in the reverse direction. So for C, yes, it's constant speed. Yes, V perpendicular to A. Is it counterclockwise? Yes. D is, once again, constant speed, it's just going the reverse way. Okay. E is Oh, now it's good. So no, it's not constant speed. So it's like e power jt squared. So it's like 2t. Yeah, sure. So constant speed v by 20 to a. I suppose that's still gonna happen, but just think about it. No, it won't happen because there's some tangential acceleration. Otherwise, how will the speed increase, right? So no, that's wrong. And what else? The counterclockwise thing. Yes, it's going counterclockwise. Okay, 23 is 10, 24. 24 is motion along a circle. Show that the vector valued function something 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 describes the motion of a particle moving in the circle of radius 1, centered 2 to 2, whatever, lying in the plane. Okay, this is just really getting boring at this point, but fine. So that this describes the motion of a particle moving in a circle of radius 1 at the point 2, okay, lying in the plane x plus y minus 2z equal to in this plane. Okay, so you have a normal vector already. Okay, you also have the central point 2 to 1. So this also should lie, right? So it's 2 plus 2 minus 2, that is 0. What? Centered at the point, circle of radius 1 centered at the point and lying in this plane. Can't be, right? So if this is lying in the plane, then the center should also lie in that plane. Yes, but the center clearly does not. Oh, it does, sorry, it's 4 minus 2. Sure, okay, so the center isn't there. Okay, fine. So you have the normal vector, you also, so you're just trying to show that, right? So you just have to decompose it essentially. Okay, so it shouldn't be that hard. So it's basically this stuff, this center, plus this stuff. So all you have to show is that the vector 1 comma 1 comma minus 2, this is perpendicular to this. Let's take the, yeah, okay, cosine t that times of this vector, and then so you just have to prove this. I'm assuming these are the bases. Just prove that these two are perpendicular to each other, and this, and here will be done. So are these perpendicular to each other? Yes, they are. Are these perpendicular to this vector? Yes, they are. Yeah, they certainly are. So there you go. So what you have is, like, let's call this thing as n. So n vector is something like this. This both of these, like, are unit vectors. So let's call this as u1, call this thing as u2. So these form an orthogonal basis, and so what you have is like cosine t of this and then sine t of that. So just doing a change of basis essentially, right? So there's nothing to prove as such. Yeah. So the angle, it's like this is your circle. So at angle t, this would be happening, right? Because the projection along this thing would be cosine t, and this would be sine t, and so we just, just have that cosine t times u1 and sine t times this stuff, and there you go. That makes sense, doesn't it? Okay, so that's 24th. It was easy to show. I think we're finally getting to some good stuff now. Okay, 25 is motion along a parabola. Particle moves to the top of the parabola from left to right at constant speed 5 units per second. Find the velocity of the particle as it moves through the point 2 2. Okay, the parabola is like parameterized. Wait, the constant speed, the arc length and all that, huh? From left to right, how is y square equal to something like this? Facing from left to right, top of the parabola, sure, 5 units per second. Find the velocity of the particle as it moves through the point 2 comma 2. So 2 comma 2 is at, so it's like 4a 2, so a is just 1. What am I doing? 2 comma 2, why coordinate being that is interesting. So the 2a thing would just be 1. So this is your, what is it called, the lattice rectum, and then so it's something like this. I have no idea what I'm doing, but yeah, so your focus is just at this point at a, I suppose. What am I even yeah, but anyway, the point is that the particle moves, it reaches some point 2 comma 2, you have some velocity, constant speed of 5 units. Find the velocity of the particle as it moves to this point. shouldn't be hard because we can figure out the slope at that point. Yeah, so it's just a conic, right? How do you find a line y1 equal to 2 times of x plus x1 upon 2? So I have no idea why they want to do it. Let's just do it the proper way. Let's not use some cheat code, but do it a proper way, right? So we should probably parameterize it so that it has a constant speed, right? Yeah, a unit parameterization. But this is just stupid. But anyway, let's just do it. So the normal parameterization would be something like, all you need to just find the. So let's say you have gone till this point at some x coordinate. What is your s value? And that will give you the relation of s versus x, right? So s would just be like integration. So for every dx you do your or just you could integrate over y. That's a better thing. So your dx upon dy stuff, that's just equal to, so x is just y squared by 2, so just like y. Yeah, yes. So what you would have is something like, so for every dx unit you obviously move in the x direction, and you also move by dx by dy. Hey, what? No, okay, for every y unit you move 1, and you also move dx by dy times dy, so square that, so it's y square over there, and you're going to integrate that from, well, so it's crazy, but it's some capital Y. That's what s is. So s is just integrate that, yeah, not good. How do you integrate this stuff? Square root of 1 plus y squared, and y be equal to tan theta, which is not going good. So tan inverse of capital Y. Oof, that devolved really bad. So just secant cube theta d theta. How do you integrate this stuff? I've forgotten. Secant square is 1 plus tan square. So secant theta tan theta is the derivative of secant theta. How will that help? It won't. That's the problem. Now what? I mean, it's okay. Okay, never mind. Intruders. So I have forgotten how to integrate this stuff. Oh god. Secant theta tan theta times tan theta. That is not a good thing, no? Integrate secant square theta, differentiate secant theta. That's probably gonna give secant theta tan theta times. So that's tan square theta. Oh, okay, cool, got it. So let this be s, sure. Integrating secant square theta, just I got tan theta times secant theta, going from 0 to tan inverse of y whatever, minus integration of, so you got tan theta times the derivative of secant theta, which is like secant theta tan square theta d theta. But then you can rewrite as a secant square theta minus 1, so this is secant cube theta minus 1, secant square minus 1 d theta. I'm just skipping the theta, never mind. So what you essentially have is like s is equal to, so just putting 0, it cancels out, ls of y, so it's just y square root of 1 plus y squared minus, so this would just be s plus the integration of secant theta d theta, which is natural log of tan theta plus secant theta. So from at 0 it's going to be cancelled in any case, so it's like sine is 0, so sure. And over here just have like y plus square root of 1 plus y squared. Okay, this was really bad. So now you have s as a function of capital Y. No, this is bad. I won't be able to solve for capital Y, and if I can't do that, I can't solve for x. Oh no. Oh, this is bad. I'm getting some sort of an implicit equation. 2s is equal to, at least I have a relation. Not good. Certainly not good. Now what? You'll just have to go the regular way, right? Use the properties of conic section, or just parameterize as 80 square comma 280, and then you do a sort of a just find the velocity's direction. That's all you have to do, because we know the velocity's direction is the same no matter whatever speed is in whatever parameterization you have, right? So you can do an a t square comma 280 thing. A is 1 by 2, so it's 1 by 2 t square comma 280. So just 2 times of 1 by 2 times t basically. And then at 2 comma 2, so t equal to 2 is where we are. Derivative is just so 2 times of t. What am I meant to t comma 1 at t equal to 2 is just 2 comma 1. So this is the direction of velocity. So you just have like 2 comma 1 upon square root of 3 that times whatever magnitude you have, which is 5. So there you go, that's a velocity. So it's 10 by square root of 3 comma 5 by square root of 3. Next, or you can have in the conic section stuff, which for some reason I skipped, me being a masochist. Okay, motion along a cycloid. Particle moves its x-factor in such a way that its position at whatever graph r of t, the resulting comes a cycloid. Okay, this is I saw this previously, didn't I? It's pretty easy to graph. This is like 2 pi stuff. Okay, what do we want? The resulting comes a cycloid. Yeah, sure. Find the maximum and minimum value of the speed and acceleration. The extreme values of and take this obviously. So velocity is just what? It's just like 1 minus cosine comma sine. So the square root of that is just like square root of, so square is 1 minus 2c plus c square plus s square is 1, so it's 2 and that, which is basically like what is just 2 the magnitude of sine of t by 2, right, which reaches 2 at worst or at the best, I don't know how to call it. So 2 comma and the acceleration, so the acceleration is just like 1 obviously all the time, it's all the time just so minus sine comma cosine. What do you have? Not minus sign, it's positive, and that's to be expected, right? So just 1 all the time. Okay, next 27 is that r be differentiable vector of t. Show that if r dot dr by dt equal to 0 for all t, then r is a constant. We have done this, haven't we? Yeah, we have. But right, let's just do it. So if r dot dr by dt is 0, then r is a constant. But what is d by dt of r dot r, right? Since it's a bilinear product, right? Bilinear meaning you can like add, so it's distributive over addition on other, never mind, you just search it up. But yeah, so what we can do is just say d by dt of r vector dot r plus r vector dot d by dt of r vector, but then it's also commutative because dot products are commutative, right? So this just becomes, I mean, okay, not necessarily, inner products may not be commutative, but in this case it is. So it just becomes like 2r vector dot dr by dt, which is also the same thing as this stuff. Okay, never mind. So if this thing is 0, then what you're saying is this thing is 0, but you know that this thing is just d by dt, the L2 norm of that's just like this stuff is 0. So what you're saying is this stuff is 0. So what you're saying is this is a constant. It's kind of basic stuff. Never mind. This was a bit too easy to prove. 28 is derivatives of triple scalar products. Show that if u, v, w differentiable vector functions of t, then come on, it's just a determinant, and then determinants taking derivative of that is it's just a product rule. Come on, it's just a product rule. I'm not even going to show that. So A done. B, I mean, really, there's no point in showing that. What you want me to do that u plus du stuff and like distribute dot product over that and then the cross product over that and all that shit? I'm not doing that. I'm just not doing that. Okay, so show that d by dt of r dot dr by dt times, okay, that's equal to this. Shouldn't be hard, just distribute and all. Just use this property, right? So what you have is like r dot r dot, it's a box product, right? So it's basically like the derivative of r r dot r double dot. I think I've seen this somewhere, but never mind. Oh, it's a binomial vector. The binomial vector is defined this way. I mean, except it's more like r dot r double dot r triple dot, but so you can replace this by velocity and it all starts making sense already. But yeah, it shouldn't be hard. Okay, now it suddenly makes sense, doesn't it? Anyway, so what do you have? You just have r dot r double dot plus r comma r double dot plus r comma r dot r triple dot. So obviously these two are 0 because of how that's just how determinants work. So this thing is there. So yeah, it's just the box product of r dot and r triple dot as expected. Or you could address r triple dot and r. There's a cyclic permutation property, right? So yeah, or you could just see that never mind, I'm not justifying it. 29. Where's 29? 29, right? Prove that the scalar multiplication rules for vector functions. What scalar multiplication? Scalar multiple rules. What rules are you talking about? Two scalar multiple rules for vector functions. What? I have no idea what you're talking about. 30. Prove the sum and difference rules. Rules for what? I think for differentiation, I suppose. So I think in 29 what they want me to do is just prove that like d by dt of k some constant r vector, that's equal to like k d by dt r vector, which is obvious, I suppose. For any sort of multiplication this would be obvious, right? It just happens to be a like a scalar vector multiplication. As long as a bilinear multiplication, it's gonna hold true. So I have no idea what you exactly want me to prove as such. I can just prove it for any bilinear product and then this follows easily. So 29 is done. 30, sum and difference rules. Seriously, no, just I don't want to do it. So I'm just gonna move on. 31, some epsilon delta stuff, easy to show really. Component test for continuity at a point, so that the vector functions are defined by this stuff, continuous at if and only if f, g, h are continuous. Yeah, okay, so once again, what's the continuity definition? It's basically like if you nudge it a little bit, if you change your t by a little bit, your r shouldn't just explode, right? So basically every sequence that every sequence tn which converges to t0, right, that should have your r of tn converging to r of t0. That's continuity, I suppose, right? Yeah. I think that's the way it was defined. I kind of forget the definition a lot, but I think that is the way it was defined, wasn't it? I think it's continuous, so this should happen, I suppose. It's convergent. Yes, that's actually the way it was defined, right? You just had the left hand limit, the right hand limit, so that, yeah, so as t tends to t0 from the left hand, what should happen is, yes, which is exactly just this. Or you could have sequence definition, or you could have an epsilon delta definition. Both are equivalent. So we'll just try to prove that the epsilon delta definition, right? So if your r is in fact converging, then what happens is that for all epsilon greater than 0, there exists some delta such that whenever your t minus t naught thing, this is like this thing is less than or equal to delta, and that kind of implies that your r vector minus r naught vector t, this thing, the norm of that, so this is just an absolute value, by the way, it's not a norm, it's just two numbers. Yeah, we don't have a t, sorry. So r of t naught is what I should say, right? Let's just call that r naught directly. So r naught, right? This is going to be less than or equal to epsilon, right? And since we are dealing with the L2 norm, what this means is you can square that, so you just have so x minus x0 squared plus y minus y0 squared plus z minus z0. So by the way, everything's like a positive number, so you don't have to worry any much. This is equal to epsilon squared, right? Now we can use the, I think it's called the Cauchy-Schwarz inequality or whatever, but what it essentially says is that this stuff is bigger than or equal to the what, just have x minus x naught plus y minus y naught plus z minus z naught squared, right? This is less than or equal to this. I think, yeah, that was a, yeah, that's I think the triangle inequality or something. Like, I keep forgetting this. Never mind. But yeah, this is a very valid inequality. How do I convince that it's actually valid? That's a good question. How do I convince you it's valid? Shouldn't this actually be bigger and not lesser? I think I'm messing up something. Yes, I am messing up something, am I not? That was the thing, wasn't it? Was the RMS is bigger than the, yeah. Oh, you should have some 1 by 3 stuff. That's how it is. So this upon 3, that should be less than or equal, so the square root of that will be like a 3, so this should be 9 over there. That happens, but then this is like less than or equal to epsilon square upon 3 essentially. So what you're seeing is your x minus x naught plus y minus y naught plus z minus z naught, this is less than or equal to, you know what, no, let's not do it this way. Instead, just do the sensible thing and say, oh, this thing is bigger than or equal to x minus x naught square. That's less than or equal to epsilon square. So x minus x naught, the magnitude of that is bounded by epsilon as well. So it cannot be that it's not converging, right? So basically for all epsilon, you can find a delta such that this happens, but then that implies this also happens, right? So yeah, you can always find a delta such that t being close to t naught implies that x is also close to x naught, and so that's kind of the definition for continuity, and so we are done, right? I don't know why I was trying to do the whole Cauchy-Schwarz stuff, but yeah, okay, this is actually much easier. 32, limits of cross products and of vectors. I mean, I think okay, that makes sense. Suppose that r equal to f, f2, f3, whatever, t tends to t naught, r1 equal to a, and t tends to t naught, r2. Use a determinant formula for cross products and the limit product rule for scalar functions to show that, okay, sure, limit product rule. Oh, okay, so it is the product rule, isn't it? Oh, okay, so you mean the product rule for scalars, right. To show that, oh, this is a fine, I mean, not a big deal, but I seriously do not want to be doing this. Fine, just, so it's in R3, isn't it? Yeah, so you got F1, F2, F3, that cross product with G1, G2, G3, which happens to be what? It's just like F2 G3 minus F3 G2, then you got F3 G1 minus F1 G3, and then F1 G2 minus F2 G1. So the thing was using epsilon delta definition. So since R is converging to A, we can use the thing that we just proved previously and say that F1, F2 and F3, all of these are converging to A1, A2, A3, where these are the coordinates of A. Yeah, and similarly G1, G2, G3 are converging to B1, B2, B3. So then this whole thing, by using the product rule, sum rule, all that, what will happen is that this is converging to A2 B3 minus A3 B2, other stuff, and which is exactly just, you know, A cross B because of the way it was done. But yeah, so pretty easy to show. I'm not going to write the whole thing, but I think you got the idea. 33 is differentiable vector functions are continuous. Show that if R is this thing is differentiable at t equal to t naught, then it is continuous at t as well. hey, being continuous like prerequisite for it to be differential? Like, how would a derivative even make sense if it's not continuous? What is a differentiable in non-continuous function? I don't think I've seen that, have I? No, I have not seen something like that. Yeah, I certainly haven't seen anything like that. Okay, fine. So something is differential. How do you define differentiality? The derivative always exists. How do you define the derivative? It's just a limit, right? So at t equal to t naught. Cool. So what you're saying is from t naught to something else, your rate of change in one thing upon another thing, that thing is approaching a value basically. So all you're saying is r of t minus r of t naught upon t minus t naught as t approaches t naught, this thing is some value. Like this is actually converging to something, right? Call it your r dash of t or the velocity at t naught, right? Yes. So once again using epsilon delta definitions, right? Yeah. Then it is continuous at t. What? Continuous at t naught as well. Oh, okay. Sorry. So basically we have to show that r of t is approaching r of t naught. Okay, cool. So for all epsilon greater than, I wrote it really bad. So for all epsilon greater than 0, there exists a delta such that whenever your t minus t naught thing is like less than epsilon, sorry, less than delta, then that implies that this stuff is less than epsilon, the norm. This stuff is less than epsilon. But then you can take this outside. It just becomes like the norm of r of t as r of t naught is less than epsilon times t minus t naught. But wait a second, that's less than epsilon times delta, right? Yes. Which let's call it as delta dash, right? So since there exists a delta, there's also existing a delta dash, right? So you can always find, wait, no, let's actually call this epsilon dash. This is getting weird. So you want to show that this thing is right. Oh, okay, so right, there always exists a delta. So what we can instead show is, come on, since it's gonna be true for all epsilon, what we can also say, it's also true for epsilon upon delta, right? This is kind of weird, right? So we want this to be our new epsilon dash, right? So this is our epsilon dash. So kind of what you're saying is that for all epsilon dash greater than 0, there exists a delta such that, so we will define your what, that epsilon to be just epsilon dash upon delta, such that, so this stuff t minus t naught less than delta, that kind of implies this. So r of t minus r of t naught, never mind all that, that thing is less than epsilon times delta, but that is epsilon dash essentially. Right. And this is true because for every epsilon dash you can have an epsilon which is just epsilon dash upon the delta, right? There exists a delta. I think I'm messing up something, but I probably am getting the gist of it. If I just say like this will be less than epsilon, you're pretty much done, right? So you just have to say delta is less than 1. Interesting. Delta less than 1, how do we show that? So for all epsilon this will happen. Okay, so if delta is bigger than 1, right, as in, interesting. Yeah, I see. Oh, okay. So the thing is, there exists a delta. Now, if that delta is bigger than 1, there's also existing a delta dash which is less than 1. Because if this inequality holds true for every single time when your t minus t naught is less than delta, it's also holding true whenever t minus t naught is less than delta dash, right? Yes. So, hmm. Right. So there exists a delta strictly less than 1. In fact, we can actually say that, right, such that this happens. And it doesn't really change anything. Because if there exists a delta bigger than 1, there obviously exists a delta less than 1. Right? Just confine it a bit. So there always exists a delta less than 1 such that, so you can rewrite the whole continuity definition as this thing. Continuity for the differentiation. So, but with this, you can rewrite it as this thing, and then this is less than, so it's epsilon delta, but then that thing is less than epsilon. So what that means is, for every epsilon, you also have a delta less than 1, such that your r minus r t naught, that thing is less than epsilon, which is exactly the definition for continuity for r of t. Yeah, that makes sense. So that's okay, we're done. 33 is done. 34 is constant function rule. Prove that if u is a vector function with a constant value c, then du by dt equal to 0. U is a vector function with constant value c. Sure. I mean, come on, who do you take me for? This is obviously correct. I won't show it. Just won't show it. Yeah. Seriously won't show it. Like, from the very definition of du by dt, this could be 0. Okay, 35. R of t equal to sine t minus t cosine t, blah blah blah, whatever. What do you want me to show? Oh, it's some computer expression. So use a SAS, no idea what that is, to perform the following steps. Plot the space, evaluate dy, okay, whatever. No, not doing it. Okay, so all of this is like this plotting stuff, which I'm not interested in. Let's move on. So that was this exercise. 35 is not important. All of this was just like some prove it's true and all that stuff, so I'm not even writing this. Okay, next, initial value problems. Okay, so you have to integrate once again. Fine. Once again, who do you take me for? I'm not a calculator. Evaluate the integrals 0 to 1. This stuff is like 1 by 4 comma 7 comma, what is this stuff, t squared by 2, it's like 1, so 1 by 2 plus 1 is 3 by 2, 7 by 4 comma 7 comma, just 3 by 2. I'm really just not going to do any of this. I have enough experience for integration. I am not interested in doing any of this. Okay, initial value, solve the initial value problems for r as a function of t. Once again, just integrate and set to 0. Like, come on, I'm not doing this. These are very simple functions. I have no interest in doing this. What is this stuff? Oh, this is slightly different. So okay, so you're given your t square r. Okay, fine, just find the velocity, then find the r thing. Not a big deal. R is located as a straight line, speed, constant acceleration, find the equation for the position. Come on, ut plus half at square is your mind. A particle traveling in your straight line is located at point one, the speed, whatever particle is. Constant acceleration. Are you serious? You're just taking me for a high schooler, aren't you? Vegetal flights in the following seriously. I'm just no. Just no. I have no interest in doing any of this. Seriously, it just seems like you have to calculate a lot of stuff. I'm not interested. Oh, okay, it's this one, the feet per second thing. So g in feet per second was what? I think it was like, I forgot it again, didn't I? It's 9.8 and then you got 3.4, I think. I'm just gonna search that up. G in feet per second square, sorry. But yeah, 32.17 feet per second square. Fine, we'll just keep that in mind. So it's 32 basically. 10, 32. That's cool. Oh, so this is where stuff comes from. This is okay. This is okay. These are some normal angles. There was something with a 20 degree somewhere in my tutorial, so I'm just seeing if that is there. No, it's not there. They must have just like come up with random numbers themselves. So all of this is kinematics, isn't it? Finding muscle speed. Shows experiment with two marbles launched towards marble V with large angle something initial speed. At the same instant, marble V was released to fall from the rest. At r and alpha units directly above the spot r units. Okay, long range from A. Sure. So A was launched, B was falling down. Model found to collide regardless of the values of V naught. Okay, what? Okay, regardless of the values of V naught. What is half GT square? It's r tan alpha. Was this mere coincidence or must this happen? How can they do it regardless of the value of V naught? That doesn't make sense. It's for every value of V naught. Okay, this is kind of good. Let's try to do this thing. So basically what we want is when this guy reaches at this point, the time and the y coordinate. That's what you want. So this is some r and this is r tan alpha. Sure. So you have some v naught. I'm just gonna think of it as vx, vy, or yeah, okay, that's okay. So r upon vx. So the time. What happened? Why isn't it? Okay, now it's working. Hey, what happened to my pen? Okay, this is not good. So your t is just r upon vx. Okay, and your y coordinate is just like, this is so inconvenient. So it's just ut minus half, it is like uy. Okay, this isn't receptive. Why? It's just really bad. Half gt square. Sure, and at that point the y coordinate of this b guy, that would just be like r tan alpha minus half gt square. So what we want is that these two should be the same. So for that to happen, you just have like, oh, this cancels. I mean, obviously that kind of cancels. Oh, okay, yeah, right, that's okay. So r tan alpha should be equal to, okay, that's obvious. This is not mere coincidence. This will always happen. The thing is, this value r tan alpha, that's what's causing this to happen. Right, math doesn't lie. It will always happen, but it's still very counterintuitive somehow. Okay, Finding from x naught y naught derive the equation. What? Seriously? Seriously? No, I'm not gonna do that. Where trajectory is crest. For a projectile fired from the ground at launch angle alpha with an initial velocity, alpha is the variable and v naught as a Planck's constant for each alpha. You obtain a parabolic trajectory showing the convention of what? Parabolic trajectory. Okay, fine, the usual parabolic trajectory. Show that the points in the plane that give the maximum heights of these parabolic trajectories all lie on the ellipse. Just find the xy coordinates. So just r by 2, which is like, so r is just like what? Just like ux uy. Driving me crazy. Ux uy upon g. Why is this? So that's r by 2, and then the y coordinate is just h. So what is h? It's half the time for, so just 2 uy upon g, half of that. It's like uy upon g. So in uy upon g, however much it must have fell down initially, is just nothing. So 2 uy upon, so just uy upon g, so like half gt square. So just 1 by 2 g times of uy by 2, so uy by g squared, just uy squared by g squared, just uy squared upon 2g. Sure, and that's the thing. So this is obvious, right? So your uy is variable. Ux is also a, what did you say? Oh, your initial velocity is constant, isn't it? Okay, then you can rewrite it. So it just becomes like u square. This is frustrating. This is really frustrating. Sine cosine point g, and this thing is u square sine square upon 2g. Right. I have no idea why it's taking. Never mind. So it's just like what? Sine square cosine square. You can probably just, yeah, sure, you probably should divide by that. It's like 4, this thing is 2, and then this turns out to be sine of 2 theta. Okay, this isn't receptive somehow, and this is like 1 minus cosine of 2 theta. Okay, what? 1 minus cosine. This isn't receptive. Okay, cool. So what does that mean? It means like x times of 2 squared, or just forget that, who cares. So x squared plus 2y, and that's just this stuff. So you gotta subtract that, or you can subtract this stuff. So minus u square upon 4g. So 2g, sorry. This whole thing squared. So sine squared. So this is equal to u square upon 4g, not 4g, just 2g squared. That's the thing. Which, yeah, that's what we wanted to show. We're done. Next thing. 30 is done. 31 is launching downhill. I to push very strong. This downhill range is achieved when the initial velocity vector bisects the angle AOR. What is AOR? Oh, it's this angle. Sure. It bisects that exactly. If the projectile were fixed uphill instead of downward. Okay, this shouldn't be so hard. Like, yeah. So you want your time to be, so your g thing can be broken down, right? Something in this direction, and then something in this direction. So this direction is actually enforcing your velocity. So it's good. You have to have as much of time as possible and just maximize the time. So to maximize the time, you just want your, actually no, it probably is more sophisticated than that, but hey, you just have to find the range. Right, just find the it's just seriously messed up. But yeah, so just have some uy. It's just, come on. So the xy stuff is just, so uxt comma uyt minus half gt square. We want to find when you have like this thing is making alpha, right? With this, let's just call this thing as beta. So this, let's just call it as beta, right? So you would have like y equal to minus tan alpha, so tan beta times x as this line. So you want that to happen, right? It's minus tan beta times this stuff. So minus tan beta, or you could just put it as x over there. I have no idea why this is. So your y is just uy upon ux times x minus this squared over there, minus g by 2, and then d is just this stuff. So it's like g by 2 ux squared and then x squared. So just, yeah, just gonna put this as minus tan beta of x, and that gives you the value of x. So x can't be 0 because that's the initial condition. So you just have g by 2ux squared x, that's equal to uy upon ux plus clearly tan beta. Yes, just gonna write this. Writing this is the harder part apparently. So you have your x coordinate. Why is this so damn hard to write this? Okay, just keep going. I need to have a graphic tablet. That is the only solution to this. I think this must be the screen guard, that's why it's not. Anyway, so you got your x coordinate. What do you want to find? The range. Oh, the range. I guess finding the range isn't that hard. Once you have your x coordinate, you also have your time. So the t value is, so you have your x once, and then you have your y, right? This is really bad. Why can't I write stuff? Okay, so your y would just be, well, yeah, just x times of, so uy upon ux minus, so g by 2 ux squared times x. So basically this stuff. So g by 2 cancels, just 1 upon ux squared times this, minus uy upon ux minus tan beta. Why can't I? Okay, that was kind of obvious, just tan beta does. I'm just silly. Anyway, so the point is it's just gonna be like x tan beta. It's just so hard to erase all this. Which is square root of 1 plus tan beta square is like secant of. It's frustrating. It's really frustrating. Cosine of beta. So this stuff upon cosine of beta. Yes, that is your distance, right? So this will be your range. Yes. So what you want, so beta is fixed in any case, so you just want to increase your x essentially, right? Yeah, I mean that's tan beta, so increase the x coordinate, that kind of also increases the whole thing as a whole. Yes. So to maximize this, so we can rewrite this. We can rewrite as 2 by g upon cosine beta. This, I'm just frustrated. Cosine of beta. And you got u squared. And it's like what? Sine cosine. So you can just take that 2 inside, right? So it becomes sine of 2 theta, comma tan beta times, so not comma, plus, sorry. Tan beta times what? So sine square. This is tan beta times 1 minus. I'm gonna cry like this. So you want to maximize that, right? Sure. So just sine 2 theta and then minus cosine 2 theta. That's like a unit vector. So it's just a dot product of that with 1 plus tan beta, right? In fact, you can take a cosine beta outside, and all of this just really makes sense at that point. So just 2u square upon g cosine square beta, and then this thing is sine 2 theta sine theta sorry, cosine beta. Now this is called frustration, minus, what was I doing? Oh yeah, sine beta cosine of 2 theta. Okay, this touch screen is not letting me do anything. So this is sine of 2 theta minus beta. So the maximum is achieved when 2 theta minus beta equal to pi by 2, which happens at 2 theta equal to beta plus pi by 2. Am I thinking straight or what? I think so. Yeah, just beta plus pi by 2. So theta should just be beta by 2 plus pi by 2. Yes. Sorry, pi by 4, which is exactly half of. So theta beta plus pi by 2 is this whole angle. So just half of that basically. And there you go. We have proved it. Once again, we want to delete all of this, and this touch screen won't let me. Okay, god damn it. 31 is done. Oh, you also have another stuff. The projectile will fixed fired uphill instead of down. What launch angle would maximize its range? Give reasons for your answer. So an x coordinate is like moving ahead in any case. So it's once again some like beta that you're going to have, except now your beta is negative. So it's all the same actually, right? It's still the same. It's still exactly the same. I think that would maximize its range. Sure, just half that angle. Yeah, shouldn't be hard, right? Yes, I suppose that's correct. Just half that angle. A golf ball is hit with the initial speed of something at an angle of 45 degree from the, what is this, TEE, to a green that is elevated. You know what? I think we should stop. It's just gonna keep on going, isn't it? Nope. It's not going to stop, is it? Wow. We haven't even reached the binary vector yet. And it's just going on. This is going to become a daily problem now. I don't think this can be done in like 1 hour. Fine, so I'll stop for now. See you in the next video. Oh wow. It's not letting me do anything. Okay. Just save it.